So here we are going to see first the tool signature. Okay. So see, tool signature, the very first method of designating the tool is what? The American Standard Association, that is ASA system for tool designation. Okay. So according to this ASA system, so see here, the tool signature is given like this. So back rake angle, then side rake angle, theta E, theta S, CE, CS, and nose radius R. Okay. So here alpha B is the back rake angle, alpha S is the side rake angle, theta E end relief angle, theta S is the side relief angle, CE is a end cutting edge angle, CS side cutting edge angle, and only one linear dimension we are having is a nose radius, Okay. So ASA system I am going to show you on the single point cutting tool. So this is isometric view. Definitely we can see it on the orthographic view also. So this is the back rake angle. This is the side rake angle. This is the end cutting edge angle. This is the side relief angle. This is the end relief angle, and this is the side cutting edge angle, and of course this is our nose radius R. Okay. So these are the 6 angles and 1 linear dimension we are having on the single point cutting tool by the ASA system. Okay. So on this orthographic view we can have here, so see here on the orthographic view we can have here, this is the back rake angle alpha B, this is the side rake angle alpha S, this is the end relief angle, this is the side relief angle, this is end cutting edge angle, this is side cutting edge angle, and nose radius is R. Okay. So these are the angles which can have in the ASA system. Now see, so in American Standard Association system, the angles are given or measured with respect to the 3 mutually perpendicular planes. How the angles are measured here? The angles are measured with respect to 3 mutually perpendicular planes. Very important. So what happened when these angles are measured with respect to 3 mutually perpendicular planes? The indication of the angles, measurement of the angles, and remembering of the angles are very easy. Very easy. Please remember, when the angles are measured with respect to 3 mutually perpendicular planes, they can very easily indicate, they can very easily measure, and they can very easily keep it in mind. That is for remembering. So that is why this is the most common method of tool designation. Very important. This is very most common method of tool designation and used across the world. If you go any of the shop floor, you will definitely find this ASA system there than any other. Okay. So, but the main disadvantage, or we can say rather limitation of this ASA system is that when we talk about the analysis of metal cutting, so in the analysis of metal cutting, what really we are going to do? So there is the mechanics of chip formation or the chip flow behavior when we are talking about in the analysis of metal cutting. So in that perspective, in a research perspective, so this designation system is not useful, because the analysis becomes difficult when we are using this ASA system. Why? Because in the analysis, when we are measuring these various angles on the tool with respect to major cutting edge of the tool, then what happened? The measuring and the analysis that going to be very easier. Here advantage is that measuring okay, indication okay, all the things for remembering it is okay, but analysis is difficult. But when you are measuring these various angles with respect to this major cutting edge, indication, measuring and remembering is very difficult, because you have to draw the isometric view of the tool. But even though analysis point of view, when you are using or measuring the cutting with respect to the major cutting edge, analysis is easier. Okay, so see here, this is mostly used on the shop floors, because on the shop floors many of the people are, say, ITIA or diploma holders, so they can easily able to identify, they can measure and they can remember those angles. But it is not used by the analyst people, research or scientist peoples, because analysis of this metal cutting becomes difficult. So I will come to that next tool signature or next tool designation system, that is the ORS. कौन सी है? The next is ORS, that is orthogonal rake system, that is ORS. So in ORS, what? The angles are measured with respect to the major cutting edge. So what happened? Analysis is very easy. Analysis becomes easy. But yes, measuring and indication or remembering of these angles, very difficult. Why? Because every time we need to draw this isometric view of the tool. Okay, so this is used by the researcher peoples, scientists or analyst people. Okay, so the thing is that what they are going to analyze, the mechanics of chip flow, mechanics of chip formation, and behavior of chip flow. Okay, so this is going to be easy when we are designating the tool in ORS. Okay, so this is the ORS system. Now in ORS, what is the tool signature? Okay, so in ORS the tool signature is what? I will write here: inclination angle, rake angle, theta S dash, theta E dash, CE, lambda and R, where I is the inclination angle, alpha is orthogonal rake angle, orthogonal rake or effective rake or side rake angle, theta S dash side relief angle, theta E dash end relief angle, C is end cutting edge angle, and lambda is approach angle or entry angle or principal cutting edge angle, principal cutting edge angle, and R is a nose radius. R is a nose radius. So this is the tool signature we can have in the orthogonal rake system. Okay, so here with respect to major cutting edge angles are measured, analysis is easier. Now see the relationship between this ASA and ORS system that we are going to understand. Okay, now see, as we have seen the two tool designation systems, that is ASA and ORS, there must be the relationship exist between these two. I am writing here the ASA and ORS, both the system. Say ASA, there is back rake angle, side rake angle, end relief, side relief, end cutting edge, side cutting edge, and nose radius R. And as per ORS, we are having inclination angle, orthogonal rake angle, theta S dash, theta E dash, CE, lambda, approach or entry angle, and nose radius R. Now if you see both of these systems, so here the end cutting edge angle is same, it is not changing, and one more thing, that is the linear dimension radius. So it is becomes constant only in both the system. Now there should be the relationship exist between the, I can write here the rake angles and the relief angles, isn't it? And one more relation there is existing between the CS and lambda, that is side cutting edge and the approach angle or entry angle or principal cutting edge angle. Now see, to get the relation between these two, I will draw here a simple diagram. Say this is our single point cutting tool, it is giving feed in this direction. Okay, so if we see, this is the major cutting edge, isn't it, and this is the minor cutting edge, or this is the side cutting edge and this is the end cutting edge of the tool. So this angle is our side cutting edge angle CS, and this angle is our end cutting edge angle CE. Okay, so this approach or entry angle you can see in the ORS here. So this angle is actually our lambda, this angle is our approach angle or entry angle, which is nothing but this angle, see, lambda. Okay, so here what the relation you can get between this CS and lambda? So this is a 90 degree. So CS is nothing but this 90 minus lambda, or lambda is equal to 90 minus this CS. Okay, so this is the first thing for this. Okay, that is the relationship between the side cutting edge angle and approach angle or entry angle lambda. So see which angle the tool is entering, that is the approach angle lambda. This is also known as principal cutting edge angle. Okay, now this is clear. The nose radius is not going to change because the linear dimension, and see this end cutting edge angle in both ASA system and ORS system is not going to change, it will be remain as it is. So three things over. Now the relationship between these rake angles and relief angles that we have to see. So of course we are having relation between these two that we will see by the transformation matrix. I am going to give you the transformation matrix. By using this we can able to interchange or interconvert these values of rake angles and relief angles from ASC to ORS or from ORS to ASA. Okay, let us suppose we will talk about these values of the rake angles. So suppose you are given with the ASA system and you are to convert it into the ORS. Okay, so ORS we are given with the ASS, that is of course the back rake angle and side rake angle is given. So how to find that this inclination angle and this orthogonal rake angle? The matrix is like this. So tan I and tan alpha is equal to this sin lambda minus cos lambda sin lambda into this tan of alpha b and tan of alpha s. So please remember this matrix. So from this how can we write? This tan I is equal to this sin lambda into tan alpha b minus this cos lambda into tan of alpha s, like this, or this tan alpha is equal to this cos lambda into tan of alpha b plus sin lambda into tan of alpha s. So you can get the formula when say side rake angle like back rake angle from ASA, you can get the inclination angle in ORS, or you can get the orthogonal rake angle in ORS, isn't it? So for again you can have this tan alpha b and tan alpha s. How to calculate? When inclination angle and when ORS is given and you are going to convert it in ASA, so it is equal to this sin lambda minus cos lambda, this is cos lambda sin lambda into tan I tan alpha. So again if you have for tan alpha will be sin lambda tan I plus cos lambda tan alpha. Tan alpha s will be what? Minus cos lambda into tan I plus sin lambda into tan alpha. You can solve this matrix. These are the transformation matrix. So these are what? Transformation matrices. Okay. Now in same fashion you can have the transformation matrix for the relief angles. So we are having cot theta s, cot theta e is equal to sin lambda minus cos lambda sin lambda into cot theta s dash and tan theta e dash. When ORS angles theta s dash and theta e dash is given, you can have the ASA, or from ASA you will have ORS angles like say cot theta s dash tan theta e dash is equal to sin lambda cos lambda minus cos lambda sin lambda into this cot theta s and cot theta e. So in this way we can able to have the conversion between the ASS to ORS or ORS to ASA system. Okay, for the rake angles, relief angles, end cutting edge angle remains same, nose radius remains same, and the conversion between CS and lambda. CS equal to 90 minus lambda and lambda is equal to 90 minus CS. Okay. Now the next tool designating system we are having, that is normal rake, normal rake system, NRS, normal rake system. So here we need to have the value of normal rake angle, normal rake angle, and theta n is normal relief angle, normal relief angle. And there is a relationship between the NRS system and ORS. There is a relation between the ORS and NRS. So here NRS system, in the NRS normal rake system, the shear plane is taken as the reference. Shear plane in the metal cutting is taken as a reference, and with that we are measuring this normal rake angle and normal relief angle. So how to get the value of normal rake angle is equal to, it is tan inverse of tan of alpha into cos of I, where I is the orthogonal rake angle and I is the inclination angle. If you have these two from the ORS, you will get this alpha n in the NRS, and you can have this theta n is equal to tan inverse of this tan of theta s dash divided by cos I. So you are having the side relief angle in the ORS and inclination angle in the ORS. You can find out the normal rake angle theta n, normal rake. This is the, so normal relief angle theta n, and this is the normal rake angle alpha n. So this is the NRS system, and fourth one is the MRS, that is a machine reference system. But this is, these two, that is NRS and MRS, this is machine reference system, this is normal rake system. These two are absolute nowadays, because see, in machine reference system, this is one of the oldest tool designating system, where the machine axis are taken as the reference axis. Okay, machine tool axis were taken as the reference axis, and here the shear plane is taken as the reference axis. So see, these are two absolute now. So maximum we are using the ASA system and ORS system. So here this is also oldest, one of the oldest tool designated system, and this is absolute now. Okay, so these are the four tool designating systems or tool signature we have seen for the single point cutting tool. Okay, thank you.